Yeah. And we're live. Excellent. I see two people. Literally, there's two people there. And there's two people in the comments. It's a Friday. Where the heck are people? They on vacation? It's a 3-day weekend. Where are they going? Oh. As more people are coming in. I'll give them a couple minutes to kind of get in. And I'll kind of go over some vague details until then, or something along those lines. Number one, supposedly, we're going to be coming back on the 25th. All you guys will be. Have you seen the updated numbers for New Jersey? Oh, man. Specifically our region, our Central East region. The numbers have never been higher. We just got a new report yesterday, and our rates are going up. Oh, goodness gracious. So the assumption is that we'll be back for midterms starting on the 25th. My plan for you guys, since I will see you next week on Wednesday, Friday, I will be reviewing midterms with you guys. Obviously, completely digital and virtual and all of that fun stuff. We'll be able to go through it piece at a time. And then we'll be able to knock out that midterm. Now, these people are popping in to say here, and then it says like 3 people in the chat. Where the heck is everybody? Because I'm going to be reviewing some stuff. Well, not reviewing midterm stuff with you, but doing other stuff with you guys today. Here's my general plan for today. Going to be somewhat of a straightforward day. But I would like to knock out a quizzes with you guys. Now, this quizzes will be in regards to nth roots, stuff that we did last class. I spent a very deliberate amount of time with you guys last class, going through different things with nth roots and simplifying them down. And now I would like to put them into practice. Now, when I say practice, I mean practice. This quizzes is a practice. Now, I will be, at some point, assigning you guys something, so be on the lookout for that. Always pay attention to Google Classroom. But yeah. Now, in terms of Google Classroom, there was the benchmark, which I'm very happy to say that the vast majority of you guys did. Thank you so much. You guys actually, on average, did it way more than the other class. I'm just saying. So I do thank you for that. But if you haven't done the benchmark, please make sure that you get that benchmark done. Yeah. It has been a crazy week. I don't know about you guys, but like you guys have been home or doing whatever. I don't know. Maybe you're working, maybe you're doing whatever. But like being here all week has just been surreal. It's like a ghost town, you know? I don't like it. Anyway, I'm going to get this thing set up. So I'm going to bring up the code for the quizzes. And I'm going to suggest that you have your notebooks out and open as a reference, because you're going to need to look at some of the problems that we have done in the past in order to see how you could potentially do these problems now on paper. I would suggest a scrap piece of paper as well, because if you're going to be getting these answers, perhaps you need to noodle these problems out a little bit. Just a thought. Let me flip my camera over and then lament the fact that you cannot see the game code, because the game code is being glared out by a giant ball of light. So I'm going to do 2 things. I'm going to write said game code in the chat, and I am going to put the game code on the board. Let's type the game code into the chat. 053529. And of course, I am going to write it up here as well. 053529. As people begin popping into this quizzes. Now, again, it's just a practice quizzes. But I definitely want you guys to put forth your full effort on this. This information is going to be vital towards the rest of this chapter. When this quizzes is complete, I will be reviewing various problems with you. But the only way I'm going to be able to review those questions with you is if I get the proper data. The only way I get the data is by you guys participating in this quizzes. Come on. I see 10 people in the chat. I see a whole bunch of people left comments. You got to get in there. While you guys are popping in, of course, you should make sure to watch the Ravens game on Saturday, simply because it'd be nice to see your future Super Bowl champions, in the playoffs. Just saying, Now, I am going to start this thing in a minute. But if you have not, I'm looking at the number of people who have signed in, and of course I can see the names of the people who signed in as well. If the code doesn't work, if you close out the window to the quizzes and try to reload it, 75% of the time that fixes it. Other classes had similar issues. 053529. It generates like a brand new code every time, which is weird. But that's what happens. But I'm going to start this thing in a moment. So definitely reload it if you need to reload that website, close it out, open it back up, turn it off and on again. If you have not logged in yet, remember that even if I click start, it will still accept you as a new player. And this will work as long as this quiz is live. So I'm going to go click it and you guys are going to get started. Remember, I'm not doing this for the whole class period. I will put it to a stop at some point. Because I would like to review some of these questions with you. So here we go. Remember, for you guys who just came in to the chat, you can still join using that code, either the code written white at the top of the page or the same code that I typed into the live stream. I'm just going to be giving you guys another couple of minutes to wrap this up, and then I want to begin reviewing. Okay. I'm about to go click that button. Here we go. And chapa. And chapa. Click. Do, 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 do. All right. Okay. So here's the goal. What I would like to do, I would like to review some of the questions that gave us the most issues. Now, there are some questions that are labeled in red, some in yellow. I want to focus in on the ones that are labeled in red first, obviously, and then work my way back to some of the yellow ones with the time that we have remaining. So what I'm going to need from you, if you do not already have them out, I'm going to need those notebooks out and open. Let's see what we got here. Now, just for the sake of argument, I am going to title this Nth Roots Quiz is Review. Today being the 21st, I'm going to label that into my notes. You can see that right there. I'm going to be able to write down the example, as I'm expecting you to as well. And then I want to like to talk about how that answer was found. So number one, I'm just going to start with this one. I will show you what I write down in a moment. But we have the square root of 81 x to the fourth y to the eighth. Now, there are different strategies that you can employ in regards to these problems. There's always different types of strategies that you can do. I'm going to be focusing between one of maybe 2 or 3 different strategies that you can employ for these problems. But the thing that I want to point out is this. This is a square root. You can tell because there is no little number right there. And since there is no little number right there, you assume that it is a second root problem. And they're expecting you to simplify. So one way of going about this problem is rewriting it like this. That's one way of going about this problem. Let me try to move that so the glare's not in the way. There we go. Now, the reason why this would be a good strategy for this particular problem is because since you have a square root, you are looking for either perfect squares or exponents that are multiples of 2. Both 4 and 8 are multiples of 2. This is going to be helpful for us. 81 is a perfect square. This is going to be helpful for us. In fact, 81 is nothing more than 9 squared. But as I'm going to show you right here, this 1/2 power is distributed to every term within the parentheses. I am allowed to do that. Move that up a little bit more so you can see it. I'm allowed to do that for this problem. And the reason I'm allowed to do that is because there's nothing more than multiplication on the inside of the problem. If there were adding or subtracting, I would not be allowed to do that. But with multiplication or division, I am. And what ends up happening is, well, this 2 and 1/2 just become a 9. This 4 and 1/2 just become a 2. And this 8 and 1/2 just become a 4. That's the answer. Now, I went the long way around to get this problem done. I really went the long way around. But I just wanted to show you the different steps that could be employed to getting this answer done correctly. Now I'm going to check the quizzes, see which one was the correct answer. It looks like D, which you can see right there. Most people picked A. Oh, I see why most people picked A. Most people picked A. 4 people picked A. And I can see that the reason why they did was because when they were going through this original problem, they realized, okay, the 81 will become a 9. The x to the fourth will become an x squared. The y to the eighth will become a y to the fourth. They got that part, but then they left the square root on the problem. You see, when you convert this thing to be a 1/2 power, and that 1/2 power starts doing its job, that 1/2 power was the square root. That square root symbol, that radical symbol, gone. Because it is enveloped in the fractional exponent power over root. Let's take a look at another one. Let's take a look at number 3. Excellent. This is another example. Perfect example as to what I'm referring to with these problems. So the example that I'm writing down, the 5th root, and I'm going to show it to you in a moment, the 5th root of 32, x to the 15th, y to the 20th, z to the 5th. Now, the strategy that I am about to employ on this problem works only because all of the exponents are a multiple of 5. The strategy that I am about to employ only works because all of the exponents are a multiple of 5, including that 32. And you're like, but the 32, yeah. But the other day, what we did was we found the prime factorization of 32. I'm going to go to my calculator, clear that junk out, and I'm going to find the prime factorization of 32. If I divide it by 2, I can do it 5 times. Let's confirm 2 to the 5th power is indeed 32. What that means for us is this. In reality, this is 2 to the 5th, x to the 15th, y to the 20th, z to the 5th. The whole thing raised to the 1/5 power. And you can see what I wrote right there. That 32, based on a very brief prime factorization, you can find out that that 32 is nothing more than 2 to the 5th power. That 5th root becomes a 1/5 exponent. And now I can do the same thing I just did in number 1. Now, the reason why this strategy works here is because every exponent is a multiple of 5. This strategy may not work if one of the exponents was like a 7. And if that were the case, ooh, I would have to do something slightly different. So I'm going to distribute that 1/5. 1/5 times 5, 1/5 times 15, 1/5 times 20, 1/5 times 5. Move that up a bit so you can see what I just did. Notice I'm always going to write my z's like that, simply because I don't want you to confuse a z with a 2. But yeah, let's check quizzes. Let's see which one they said was the correct answer on the quizzes. Looks like B. Looks like B. What did everyone choose? Oh, it was split between B, C, and D. It's like a 3-way split. I can see C. Well, with C, you lost the Z. And with D, you never simplified the X and the Y. Or you oh no, you like subtracted. Oh, yeah, that's a problem. That's what the answer should have been. Let's take a look at another one on the quizzes. Ooh, number 8. Oh, heck yeah. Oh, yes. Let's take a look at this one. Now, this is a problem where the strategy that I just did, unfortunately, you can't employ it directly that way. You can't. With this problem, I'm going to have to break out a new marker for this one. Hold on. There we go. There's the problem right there. Yeah, I'm going to break out a new marker for this one. Go away, old marker. Let's just say it made it in. Why do I do these things to myself? Okay. I'm breaking out a brand new marker for this one just because I love this problem. And I'm so glad. How many people got it right? 3 out of 8. Okay. All right. This problem can't be done the same way as we just did. It can start the same way, but it can't go the same way. The way we start this problem, the way we start any of these problems, you're going to want to find a prime factorization, specifically of 48. So I'm going to go to my calculator. That's not my calculator. Clear that junk. 48 divided by 2. I could do it again. I could do it again. I could do it again. And there's a 3. Okay. So I was able to divide out 2 4 times, or 2 to the 4th power. Let me confirm something here. 2 to the 4th power, that's a 5. 2 to the 4th power times 3 is 48. There's the prime factorization. Okay, go back over here. Let me rewrite the problem a little bit. The fourth root of 2 to the fourth power times 3 to the first power. Move that up over the glare. Times, now I'm going to change something very drastic in this problem in a moment. Zoom in on that junk. I'm not going to write the v and the z the same way I normally do. 2 to the fourth, 3 to the first, that's the prime factorization of 48. But I want to do something to the v and the z. First, I'm going to change the v to be that. V to the fourth, because this is a fourth root on this problem. Something I talked about last time and something that I want to re-emphasize today is the only way that you escape a root is if you have the same exponent or a multiple of that root. For example, if it's a fourth root, typically you can only escape if you have an exponent that's a 4. Or an exponent that's a multiple of 4. In this case, 8 would work, but let's just, for the simplicity of it all, let's just make them 4 and 4. The z, ooh, sorry z, you have a 13. But you can break up that z. You can break up that z to be z to the fourth, z to the fourth, z to the fourth, z to the first. The reason why that works, well, you have 4 and 4 and 4, which make 12. And then one more, which makes 13. That's the z to the 13th, except I broke it apart. Now, each of these terms, I'm not actually going to write it out, but each of these terms has a fourth root being applied to it, or a 1/4 exponent, if you will. And when that exponent is applied, or when that root is applied, this too escapes. I mean, it loses its exponent, but it escapes. So does this v, so does this v, so does this z, so does this z, and so does that z. The other two, that 3 and that lone z at the end, sorry, sucks to be you. You can't escape. You're stuck. You're left behind inside of that root. This results in the following answer. Everything that escaped, 2v squared, because it was v times v, z cubed, because it was 3 of them, times the fourth root of 3z, the only two terms which couldn't escape. Let me move that up a tiny bit. Yeah, there we go. Now I'm going to check that against the quizzes in a moment. But that is the answer. That is the simplified answer. The 48 couldn't escape by itself because it wasn't a fourth root power. But it was hiding a fourth power, which was allowed to escape. The v to the 8th had the proper exponent. Thus, there's no more v inside of this radical at the end of the problem. The z couldn't escape by itself, but once it's split off into these fourth powers, they could escape. But unfortunately, one little z was left behind. Let's check the quizzes. Chapow. Nope, that's not the quizzes. Ba-pow. Ba-pow. Yep, 2v squared, z cubed, fourth root of 3z. Oh, nice. A lot of people chose the last one, which had a z squared on it. And then it was kind of evenly split amongst the other two. Huh. Okay. And then I believe there was one more red question. Yep. It was this one. Oh, nice. 3 got it right out of 9. Average time, 12 seconds. Okay. let's take a look at that one. The fourth root of 256. By the way, I do have a couple other questions that I want to do from this quizzes. I believe one of them had a 4096 in it, but we'll deal with that a little bit. Let me flip my screen over. There we go. There's the example that I have. The fourth root of 256, a to the 12th, b to the 8th, c to the 4th. All of those variables have an exponent that's a multiple of 4. So perhaps I could employ that strategy that I did at the very beginning of this quiz's review. And I will. But the 256, I'm not as familiar with the 256. Let me go to my calculator. Clear that junk out. 256 divided by 2. How many times could I do this? 1, 2, 3, 4, 5, 6, 7, 8. Let me just confirm that. 2 to the 8th power, 256. Nice. So I know how I'm going to rewrite this problem then. I know exactly how I'm going to rewrite this problem. Since all of the exponents are a multiple of 4, I can write it like this and distribute that 1/4 power. Now, again, 256. What the heck? I don't know about 256. Well, I didn't either. You go to your calculator. It takes you moments to do a prime factorization, and then you go from there. I'm going to distribute that 1/4. It's going to get me 2 to the 2nd power, a to the 3rd power, b to the 2nd power, and c to the 1st power, which I then can just rewrite like this. Because, well, 2 squared. The question is, why 1/4? Because, and if I go back to the quizzes and make sure I didn't, yeah, I wrote it correctly. This is a fourth root. And the phrase that I taught you guys from a couple class periods ago was whenever you see a root or a radical or a fractional exponent, I want you to remember the phrase power over root. And the idea of power over root, power is 1, root is 4. The bottom of the fraction indicates the type of root that you are attempting to perform. For example, clear that junk out. 81 to the 1/2 power gives you a 9. Just like the square root of 81, because they're performing the exact same task. A square root is nothing more than a 1/2 power. A fourth root of 256, and you can see that here as well. The fourth root of 256 is nothing more than the number being raised to the 1/4 power. By definition, that's what a root does. It's very strange, raising things to fractional exponents. But that's how the math ends up working out. That's what they look like. Very strange. I have a couple more problems that I would like to do. But I got to find that 4096 problem. Oh, I definitely want to talk about number 15. Oh, okay, 15's on my list. 15 is on my list. 13 might be on my list. Now I really don't know if I want to do the 4096. Ooh, 5 is on my list. There's the 4096 problem, but now I don't know if I want to do that one. No. I changed my mind. We're going to do number 5. We're going to start with number 5, and then I have a couple at the bottom that I want to try. Here's another fourth root problem. Fourth root of 64. Oh, pow. Now, just for the sake of argument, let me type in the fourth root of 64 into the calculator. You could do math, the fourth root of 64. Pow, and it spits out this decimal. Ooh. Again, please don't type it in as 4 times the square root. That's not the same thing. That number, 2.82 and change, whatever, that number, when multiplied by itself 4 times, you can see gives you exactly 64. But that's not the decimal we need. It's not. So instead, I'm going to do a prime factorization of 64. 1, 2, 3, 4, 5, 6. Just confirming, 2 to the 6th power. Yep, 2 to the 6th power is 64. You don't need to memorize that stuff. You just need to know how to very quickly do a prime factorization. Now, here's the issue that we're faced with. You can't take a fourth root of a 6th power. Instead, I'm going to have to try something slightly different. I'm going to have to split up that 2. And I'm going to split it up to be the fourth root of 2 to the 4th times 2 to the 2nd. That is much more interesting. The fourth root of 2 to the 4th, well, that just becomes a 2 because the root and the power cancel each other out. However, the fourth root of 2 squared, oh, can't do it. This escapes to become a 2. This becomes 2 times the fourth root of 2 squared, which is just 4. It's not the only way you can write that answer, but that is probably the simplest way you can write that answer. It just is. It's very strange. Check quizzes. Chapow. Nope. Wow. The 2 times the fourth root of 4. Yep, there it is. A lot of people chose B. I can see why you chose B. Yeah, but that unfortunately is not the answer. There are just a couple more problems I want to try. Which one's the one you guys took the longest on? Was that the first one? Yeah, it was the first one. You took 260 seconds on that one. It's the next longest one. I saw 44. I saw 110. That is a good one. Okay. 124 on that one. Okay. 33 on that one. Okay. We'll do number 15. I was just debating which one I actually wanted to do. Number 15. I'm going to read it, and then I'm going to write it, and then I'm going to show you. -10 times the square root of 567 times x cubed. I don't know what the heck to do with 567. It's a square root, but I don't know what to do with 567. 567 is not a perfect square. And I can't divide it by 2. Well, I guess I can still do the prime factorization. Yeah, I guess that's what I'll do. Clear that junk out. 567. I can't divide it by 2, so let's divide it by 3. Oh, it worked. Do it again. Do it again. Do it again. That's a 7. So 3 to the 4th power times 7. Oh, wow, it worked. All right, let's do that. So I'm going to rewrite this problem. -10 times the square root of 3 to the 4th power times 7 to the 1st times x cubed. Okay? Prime factorization, step 1 done. What can I do now? Well, the only way you escape a square root is if you have the proper exponent of a square, which none of them do. But I can split things up. I can split it up where it's like -10, the square root of 3 squared, 3 squared. The 7 stays the same. And then the x cubed, I can break it up like this. Let me move it out of the glare for you. That may or may not be helpful. Now, move it up here. Yeah, I'll move it up there. There we go. Now, that is helpful because now I can see what escapes and what doesn't escape. This 3 escapes, this 3 escapes, this x escapes. Nothing else does. And there's a -10 out front. Okay, so 3 and 3. 3 times 3 is 9. 9 escapes. Multiplied by that -10 gives me -90. That x escapes. And then the 7 and then the other x are left behind. Is that even one of the choices? Oh, yeah, it is. It is one of the choices. Go me. Nice. Okay. I would like to try one more problem. And I believe it's this one. But I want to double check the other one that I wanted to do because I do have the time to do it. Yeah, it's going to be this one. Number 13. Last problem of the day. And then I'm going to send you on your merry way. This is the third root of -256. You are allowed to take the third root of a negative. In fact, you are allowed to take the odd root of a negative. -1 times -1 times -1 gives you -1. -1 cubed is -1. The cubed root of -1 is -1. All of that stuff works. So the -1 is going to get to escape by itself. What about that 256? I got to do a prime factorization here. Clear that junk out. 256 divided by 2, divided by 2. So 1, 2, 3, 4, 5, 6, 7, 8. 8. 2 to the 8th power? 2 to the 8th power? Yeah, it's 256. How about that? Okay. So this would really be the third root of -1 times 2 to the 8th power. But again, an 8th power cannot escape a cubed root, but I can break that thing up. I can break it up to look like this. The cubed root of -1 times 2 cubed times 2 cubed times 2 squared. Ooh. Yeah, that'll work. That'll play. Because, well, 3 and 3 and 2 make 8. That works. According to our exponent properties, that works. I'm keeping the -1 separate. But the rest of that works. It's a cubed root. Now, again, -1 is allowed to escape a cubed root. I just talked about the details behind that over and over again. This 2 can escape, and this 2 can escape. But unfortunately, that remaining 2 squared can not. As a result, there's a -4 out front because -1 times 2 times 2. And there's the 2 squared on the inside, which is also a 4. So after all of that, it's -4 third root of 4. Let me double check quizzes in a moment. -4/3. Oh yeah, look, it's a B. Yeah, I did it. Woo. Just one of those weird things. Now, obviously, I just had you guys redo the benchmark. Again, I apologize for that. If you haven't, get it done. That was due yesterday. I will be assigning you something before I leave here today. And then next week, we are reviewing for your midterm. It's going to be pretty straightforward next couple of weeks. That's where we're at. The time is approximately here at 10:22. I am going to begin wrapping up a nowish. Just wanted to give you those reminders. And of course, if you have any questions, you can email me. Yeah. But in the meantime, take your things, leave my classroom, social distance in the hallways, because I'm going to sign off in a moment. So bye-bye. 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 So people wave bye-bye. Bye-bye. I don't know how people wave goodbye. All right, get out.